Right, guys, I want you to focus. The matrics, you need to be listening big time here. In grade 11s, you're going to be doing this. 10s, you don't have to worry at this stage. But if you want to do it, follow me. Grade 12s, just to revise what you did in grade 11, I want you to watch this very carefully. You've got to sketch this graph. Well, number one, there's a coefficient here, and that is going to be very sad. It is negative, so the graph is unhappy. That's very important. But now we've got a problem. Normally, you want to have brackets squared. You want to be able to get your axis of symmetry. Now, matrix, there's two ways, if you remember how to do this, when you sketch this graph. Watch what's going to happen. Okay, we can complete the square. Not a nice method, but let's do it anyway. Let's see. The first thing I do, I haul out the negative and I change the signs. Okay, when you take out a negative, don't forget to change the signs. Okay, now what's the next thing? Well, in completing the square, what are we going to add into this? Okay, we've got our negative on the outside, we've got our x squared, our minus 2x, and our minus 3. But what we do, we add in half the coefficient of the x all squared. So what it is, it's you take this guy, that number there is rewritten there, but and you also do it there. Okay, but what we're doing is we take that and we divide by 2. You're always going to have this structure. You add it in and subtract it, and that minus 2 goes into there. Okay, so that's completing the square. Okay, now what does this give us here, if we look at that? Well, just me backtrack a little bit. This guy is going to give you minus 2 over 2, which is negative 1 all squared. Okay, so that's negative 1 all squared, and we subtract negative 1 all squared with this. So let's see what we then get. Okay, now look at this. It's very important. So it's minus 1 all squared minus negative 1 all squared. Be very careful here. You can't multiply those things. You've got to do the exponent first. Okay, if you do that, big time shoe shine, losing marks. Okay, so what do we have here? Fx is equal to, now, what we've got here, I'm just going to write this down quickly because many matrics battle with this. This guy is x squared minus 2x plus 1, this little guy here. Now, if you factorize him, he goes x minus 1, x minus 1, which is actually, if you think about it, 2 brackets, or the thing squared. Now, careful with this. This is minus 1 squared, which is 1. 1 times negative 1 is negative 1. Then we back to normal. Okay, so what can we then do? We can then say, okay, fine. All right, this is minus x minus 1 squared minus 4. Now just bring the negative in. Put the negative next to the brackets, and then the minus times the minus is plus. And guess what? We back to square one. We back to normal. Isn't this amazing? Check at this. We've got that there. Now what do we then do? We can get the axis of symmetry. Now how would that work? Very simply put, okay, the axis of symmetry, you simply going to, now watch this, circle the guy in the brackets, that's why we completed the square, and put him equal to 0, and we get x is equal to 1. Now notice, if it was x minus 1, the axis of symmetry is a rebel child. It goes the other direction. So it's got x minus 1, put it equal to 0, and x is 1. So there's a shift to the right. Your basic graph x squared shifts to the right. Okay, be very careful with this. Okay, so this, and I'm going to write this down. This is so important because we're going to need this later on. When you see x minus 1 like that, okay, don't get confused and say you're going to the left one, you're shifting. This is actually a shift of 1 unit to the right. And how I do it, this is a little method I use. I take the x minus 1 and I put it equal to 0. And then what do I get? I get 1. That's a positive number. It's a shift to the right. Okay, it always works. So if it was x plus 1, it's a shift to the left. Okay, if it's x minus 1, it's a shift to the right. Okay, remember in the previous example, it was x plus 1 equals 0. So x is minus 1, a left shift. Okay, I love this. Okay, now watch this. Matrix, this is good revision. Okay, so your p for your turning point is 1, and the y value of the turning point is 4. So remember, This is so critical, people, when you do it. Okay. This here, that is going to be the X of the turning point, and that is the Y of the turning point. Okay, so what do we then do? Now let's move on. Okay, that was the one way of getting your turning point, which happens to be, if we just summarize it here, X is 1, Y is 4. That's your turning point. Put that equal to 0, get the 1. There's your X value, and that's your Y. Okay, now people, in the next segment of the lesson, what we're going to do is we're going to look at another method of getting the turning points with this particular example. Don't go away, stay with us, and we'll be back for some more wonderful mathematics.